In this next video, we're going to look at something called the quadratic formula. Previously, we found the zeros or the roots of a quadratic by factoring. A way to avoid factoring, or a way to find roots that are not possible by factoring, is to use the quadratic formula. Given a quadratic in the form ax squared plus bx plus c equals 0, the roots or zeros can be determined using this formula here. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's try it out. So using the quadratic formula, let's solve the following quadratic equation. 2x squared minus x minus 3 equals 0. In the formula, it has the letters a, b, and c, which correspond to the coefficient attached to the x squared, the coefficient attached to the x, and the constant c. So in our example here, we have a equals 2, b equals negative 1, and c equals negative 3. So using the quadratic formula, we get x equals the negative of b plus or minus the square root of negative 1 squared minus 4 times 2 times negative 3. All divided by 2 times 2. So all I did was replace the corresponding letters by the values given in the quadratic equation. Next, let's simplify. So the negative of negative 1 is 1. Then we get this plus and minus. And then we have negative 1 squared minus 4 times 2 times negative 3 gives us 1 plus 24, so the square root of 25, all over 4. Now with this one, we get 1 plus or minus square root of 25 is 5, all over 4. So that is what x equals. And since this is a quadratic, that means there's a possibility of two answers, and that's what the plus and minus represents. So we have x1 equals 1 plus 5 divided by 4, and x2 equals 1 minus 5 divided by 4. And going further, that's 6 over 4 and negative 4 over 4. And we get the answer 3 over 2 and negative 1. So using the quadratic formula, we didn't need to factor our expression. We found that the roots to this equation are 3 over 2 and negative 1. So recall we have a quadratic that opens up, and we just discovered that it has a 0 at negative 1 and a 0 at 3 over 2. Notice no factoring, just using a formula. This one is factorable, and we would have been able to determine the same x values using our factoring method. Let's look at some more examples. So next one, we want to solve this complex quadratic equation. First of all, let's get rid of those brackets. So that gives us 15x squared minus 12x plus 2x equals x squared minus 4x plus 12. When solving quadratic equations, we need to move everything to one side. So I'm going to move everything to the left side. So I'm going to end up with 14x squared if I minus the x squared from the right side. If I collect like terms, negative 12x plus 2x, that gives me negative 10x. Adding 4x to both sides gives me negative 6x. And then minusing 12 from both sides gives me negative 12 on the left side. Now let's use the quadratic formula. We're going to need an a value, a b value, and a c value. So we have negative 12, negative 6, and 14. So we write x equals the negative of the b value plus or minus the square root of the b value squared minus 4 times a times c, all over 2 times a. So let's simplify our expression. We get positive 6 plus or minus, and then we need to determine what is underneath the square root sign. So try that. So we end up with 708 all over 2 times 14, which is 28. So we end up with x1 equals 6 plus the square root of 708 divided by 28, and x2 equals 6 minus the square root of 708 divided by 28. Next, we're going to use our calculator since 708 is not a square number. So we end up with approximately 1.16 for our first zero. And try this yourself and see if you can get the same number. And then for our second zero, we get approximately 0.74. So again, we have a quadratic with two zeros, but these ones we would not be able to determine by factoring the equation above. Let's now change and look at a word problem. So a toy rocket is launched with an initial velocity of 180 meters per second. The height of the rocket in meters can be modeled by h equals negative 5t squared plus 180t, where t is the time in seconds. How long will the rocket stay above 350 meters? So we see that we have a y-intercept of 0 since the c value is 0. So this will be a parabola that goes up, comes back down. Since the a value is negative, it's a downward opening parabola. We want to determine when the height of this rocket, or how long this rocket, stayed above 350 meters. So from here to here is where it's above 350 meters. So what we're going to look for is the intersection of this red line with the green parabola. So we start by saying let h equal 350. So this gives us that 350 is equal to negative 5t squared plus 180t. So remember that h is our what? Remember that h is on our y-axis, and that is in meters, and time is along our x-axis, and that is in seconds. So to solve this equation, we need to get 0 on one side. So I'm going to move everything to the left side. So that gives me 5t squared minus 180t plus 350 equals 0. Next step would be to factor and find the roots. However, in this one, I'm going to use the quadratic formula. So we have that t equals, instead of x, negative b plus or minus b squared minus 4ac over 2a. For some of your homework questions, practice writing this out to help you memorize the formula. So again, we have our a equals 5, our b equals negative 180, and our c equals 350. So subbing this into the quadratic formula, this gives us the negative of negative 180 plus or minus the square root of negative 180 squared minus 4 times 5 times 350, all over 2 times 5. So let's simplify this equation. So we have 180 plus or minus. Let's figure out what's under the square root sign, and it's all going to be divided by 10. So let's check our work. So I get to 25,400. So therefore, time 1, when it first reaches 350 meters, is equal to 180 minus the square root of 25,400 all over 10. And when it comes back down to 350, that is at 180 plus the square root of 25,400 over 10. So again, hits here the first time, and the second time it comes back down to 350 meters. So using our calculator, let's approximate these t values. When does this happen? So the first time is approximately 2.06 seconds, and the second time is approximately 33.94 seconds. So the question is, how long will the rocket stay above 350? Well, we have the two times, where it started and where it ended. So we need to subtract those two times to determine how long it stayed above. So we're going to take T2 minus T1. And if we subtract those two times, 33.94 minus 2.06, we get 31.88 seconds. So therefore, the rocket